All right, so I'm gonna try not to be such a rambling guy anymore. Well, last post I was allowed to be rambling because I was returning to it. Okay, I'm rambling. Nope, stop it, Mark. So instead, I actually have a bit of an agenda to go through. So there's 4 topics I'm going to talk about. One of them is calculation versus recall, parameter sweep, interpolation training, and perspective training. So the thing is, eventually we are going to get to the training stuff. Don't worry, it's coming. But I'm going to start talking about the role of practice in training. Like practice is a part of training, right? We gotta take these terms. We gotta start separating them so we understand just exactly what it is we're doing at any given time as we're trying to improve and how it actually makes you better at a thing. So the first topic is going to be calculation versus recall. And that should be pretty obvious to you. Like we can take calculating pi, for instance. I don't know how to calculate pi. Like I don't even know how to calculate the digits of pi, but what I can tell you is that pi up to the 32nd decimal place, I'm going to shut my eyes right now, and it's going to be 3.141592653588979932238462643383279. And you can check me on that. All right, that's recall. I'm not doing any calculations. So the thing about recall is recall allows you to skip performing calculations, right? If we try to perform multiplication, like 5 times 7, I can tell you right now that's 35 because I memorized a thing called a multiplication table. That's like a lookup table, right? That's recall. That's not calculation, right? If you wanted to calculate, 5 times 7, you'd have to take 5 and you'd have to add it to itself 7 times, or you'd have to take 7 and add it to itself 5 times, right? I'd have to take 5, okay, then 10, and then 5, then 10, then 15, then 20, right? Then 25, 30, 35, right? That's doing it through calculation. And even then, my knowledge of the fact that 5 plus 5, that it goes 5, 10, 15, 20, even that is kind of based off of a recall, right? Because I'm not counting them, up like that, right? So this is the thing about recall. Recall is super powerful, and it can stand in for calculation. But the question is, how do you take those recalled figures? How do you take the 3.14155, right? How do you take that and jam it into your freaking head? Because the brain does not just bake things into memory. It doesn't just bake them into your memory the first time you get that information. It kind of bounces off your head because, like in the olden days, here, I'm going to show you something. Computer, pause recording. All right, yes, I have here in my hand some historical artifacts. Okay, so when it comes to memorizing things, all right, this is a floppy disk, right? Oh my goodness, this thing is very old. And the thing about this diskette, not just a floppy disk, we call it a diskette because it's the smaller version. They have this thing called a read-write switch. There's this little tab, right? You can see there's a hole in it, right? And you can just flip that. That makes it so you can read, this makes it so you can write to the disk, right? And then if you do that, now it is write protected. It means you can't write anything. So I think that for the most part, people walk around with their write protect switch open like that. So they can't, you can't write new memories just like that. And there's a reason why, right? It's because, we don't walk around memorizing all the little freaking tiny details and all the trivialities. Computer, pause recording. All right, so we don't memorize little insignificant details. And the reason why is because, you know, our brains would just overflow with information. And one thing I want to say is that recall works automatically and unbidden. It means that as soon as your brain kind of takes a piece of information that it's learned, if it works like a search engine, right? Whenever the topic comes up whenever there's a topic that comes up that is related to a thing that you have in your memory, and there's a neural pathway to it, right? It kind of it's made an association, right? So these things come up. So if your brain constantly just remembers every stupid little piece of detail, then what'll happen is your mind will dredge up something from your memory. And sometimes that thing will dredge up another thing when you recall. And basically, as you recall one thing after another, it dredges up additional memories that are related, right? So that's what the memory does. The memory, it works by dredging up related things, which is why whenever I memorize the 32 digits of pi, right, each digit or each phrase of numbers, so each grouping of numbers, will dredge up the memory of the next grouping of the numbers, which dredges up the next grouping of the numbers. And if we went around constantly memorizing all stuff and we had our write protect switches, like if we weren't write protected all the damn time, like we would just, our brain would get overfull with like musical jingles from advertisements. Like we would never be left alone with our own bloody thoughts. And there are people out there, like, you know, savants who memorize all the little details, right? They can do that. They have like the eidetic photographic memory. But I tell you, man, when they see something, they can't unsee it. And their brains are like, they have difficulty functioning in regular society and regular life. And it's like, yeah, it's that kind of crazy ass memory, which is constantly memorizing everything, is a problem in many cases. And so don't go wishing for it right away. Okay. But be that as it may, there are some things, you know, recall's a powerful thing, and we want to be able to store some of that information because it's actually useful to us whenever we're trying to learn a skill. And the thing is this is a laborious process, right? Some of you, I'm coming right at. A lot of people will say, "Oh, you should do this, you should do that." I'm like, yeah, but there's a really good reason why it's going to take a sacrifice to learn it, and you're going to be, and there's going to be times where you feel that it's like it's not worth it because you won't know, you just don't know what it's like until you actually have it. I can only demonstrate what it's like to have it. Like beatboxing is a skill where it's highly powered by recall, and it's a performance skill. And in some ways, drawing is kind of a performance skill. It means that when you're trying to create art that has emotion and all that stuff, right? Like you can't be wasting time in calculation. You can't be counting your fingers. You can't be like trying to recall a whole bunch of book knowledge and trying to calculate that stuff. It gets in the way. It's stifling. So you gotta. So the thing is that we have to train your recall. That's why this is important, and it's why we can't skip that step. All right. So let's talk about calculation and how it's going to work with drawing. Maybe what I should do is I should bring up here something like Wings 3D. Let's talk about the calculation itself. And then we're going to start with a piece of 3D software. So, hang on. Let's see. I'm trying to remember how to actually zoom in and out on this thing. Or maybe, I know what I have to do. First we got to that's what it is. Okay. So, let's start with this cube, because this cube is full of things to be calculated. If we look at this thing straight on, it looks like a square, right? As I tilt it back, we've got these two lines which are going to go back to a vanishing point like that, right? That vanishing point is wherever this long line is kind of going off into the distance, right? So that's more or less where that vanishing point is. And as I turn it, right, we can see that, oh, there's another vanishing point way off there. As I turn it, it comes into view. The other vanishing point goes zooming off to space. And there's actually, you know, several vanishing points. I think if I turn off, we can't make it so it draws back faces. Okay, that's fine. In fact, it's easier if I show you like this. You can see these three lines here, these three edges. They're going to go up to a vanishing point like that. If I look down and up, right, those vanishing points are all moving around constantly, right? So you're going to have to. Oh, right. We can look at other things, like maybe if I just grab these two edges. Okay, right? Just look at this one angle in here. In fact, maybe if I just put it to face mode here, we're just going to grab the face of that. Look at this angle, right? As I look down this way, right, it becomes a wide angle, right? It's so wide that at this point it turns flat, and now it inverts, right? So we can see how this angle goes between 90 degrees, right? Becomes a square angle. Now it becomes very obtuse. Obtuse means any angle that's larger than 90 degrees, to the point where that angle increases until it hits about 180 degrees, and then it begins to reverse, right? Until it hits about 90 degrees. And when does it hit 90? It hits 90 as soon as we hit that little. Actually, no, it hasn't hit 90 yet. It hits 90 about there, okay? Kind of, right? That's when it hits 90. And oddly enough, all the other angles hit 90 degrees at that moment as well, right? That one hits 90. They all hit 90 at that point. But in this case here, right, we can see that this thing is becoming, oh, right. Let me turn off there. Okay, so we're going to switch into orthogonal mode. So we're turning off vanishing points, and we're just making, it feels so weird looking at it like this, right? There. Okay, so it's 90 degrees. We can see it's becoming very obtuse. It becomes very obtuse, and then it becomes a 90-degree angle again, right? And we're just talking about, you know, this corner and that corner, right? We're just trying to describe the trend of what's going on. However, if we look at the side corners, right, these are becoming very cute, very kawaii ugu. They're very cute. No, they're acute, A-C-U-T-E, okay? So we can see that they go from 90 to an acute kawaii ugu angle until they kind of disappear and become 0 degrees. Then that value increases until they hit 90 degrees when we're looking at it straight on like that, right? Then what happens if I start rotating this thing? Oh, now this is where things get really freaking weird. Okay, so in this case, if we throw away if we don't care about vanishing points, let's just track one of these corners, right? It's a very obtuse angle. When it hits here, it becomes 90 degree. It becomes a square angle. Now it's becoming kawaii ugu and very acute. And then, you know, once it hits here, it hits 90 degrees, right? So that acute angle becomes not so cute until it's very, very wide, and then it becomes super wide, right? It becomes obtuse, and then it decreases. So the moment that corner passes the middle, right, it starts to get more and more like a right angle or square angle, and then it becomes more acute. So this is where it you know, and these are the transition points, right? So here, this is where it starts to change. It's getting wider until boop, it stops getting wide. Now it starts getting, this angle, that corner is getting wider. Now it starts getting narrower, right? Starts getting much more acute, and then it starts getting wider, right? So, and if I spin this thing, we can almost kind of see that it's almost like there's a circle. All of these points are inscribing an ellipse. Sorry, not a circle, but an ellipse, an oval. And the other thing that's kind of useful to know is that, you know, whatever one corner is doing, the opposite corner is doing it as well, in the case of a cube, right? So while this corner is getting narrower, so is the other side, right? You can count on it. And then if I start, turning this thing here, we'll turn perspective back on. We can also see things like these angles here on the corners, on the sides, right? Like those corners are getting narrower, but oddly enough, the far corners are getting wider, right? So we're just observing things in an analytical, calculative fashion. The reason why it's good to have the calculation is because this way, when you start drawing things, you're not thinking to yourself, why this, why that? It makes it make sense, right? We're not just, and the other reason why we want to learn calculation is that because you don't have any recall yet, because you haven't built up your recall library, when you're turning something, you're like, oh shit, should I make it, more acute kawaii ugu, or should I make it more obtuse? You can calculate the result. So calculation allows you to create the data that's not there. The only thing I want to see, one thing I want to see about calculation though, is that, man, it really puts a wrinkle in your brain. Like it's very exhausting. Recall is easy and fast, right? But calculation is very, very it burns energy. It burns a lot of energy. And I tell you, like, when you get good at drawing, it means that you put a lot of things into recall and you don't have to burn so much energy. And the thing about the human body, or I should just say living things in general are highly evolved to not starve. And not starving involves burning less energy, being really, really efficient. But sometimes it's a bit of a short-term plan that makes it harder, it obstructs our long-term plans. So, it's good to learn the calculation. You might have to learn the longhand multiplication and the longhand division so that if you are dealing with a number that is not in your multiplication table, you can still calculate the result of it at some expense. And the thing about practice is that when we start doing this practice stuff, you're going to be doing a lot of calculation. You're going to be doing so much calculation. You're going to be doing calculation that occurs over permutations. So a permutation is like when you're dealing with a multiplication table. Here, let us look at a multiplication table. Right? This is a multiplication table or multiplication chart. And so there are two parameters, right? You're multiplying one number by another, number A versus number B. And so number A can be any number between 1 and 12. Wow, this one goes up to 12. My mental multiplication chart only goes up to 10. Right? And number B also only goes up to... Why do they go up to 12? You tryhards. You fucking tryhards. Okay, fine. Here we go. Here's I need the smoother brain one, okay? Oh. So a permutation, right? Permutation means, A times B. Is it 1 times 2, right? So it's, that there's 2, right? Is it 5 times 4, right? So there it's like 20. Each one of these possible combinations of A and B is called a permutation. And so a multiplication chart or multiplication table means that you're memorizing all of the possible combinations, permutations, combinations, same bloody thing, right? You're memorizing all of the permutations of the parameters. And the parameter A versus parameter B, variable A versus variable B, right? So parameters. I like this one even better. Oh, this one is called, except it goes up to 12, you tryhards. So when you're practicing things like drawing cubes and drawing angles, right? We're going to be dealing with the permutations of maybe this rotation in this y-axis versus rotation in the x-axis, right? So you're dealing with those permutations, and you're gonna have to calculate, and you're gonna have to calculate in a ordered, sweeping fashion. So it means that when you're doing your calculations, you'll be drawing cubes that rotate like this. Oh, hang on, let's turn that off. Okay, we're gonna be rotating it. We're just gonna be doing one drawing after our next, doing it in something I call a permutation sweep. Because we're finding all of the permutations of the cube in one particular axis, and we're just rotating. The thing that I can tell you is you don't have to do it for like a full 360 sweep. You know why? Because the wonderful thing about the cube is that this angle looks exactly the same as this angle. You literally only have to sweep by 90 degrees to get enough that you can just replicate. You can just repeat this, right? Because that's the same as that. That's the same as that. This sweep is the same as that. So like there's shortcuts. Don't worry, man. It's like I'm going to be giving you shortcuts. It's not that bad. Not that bad. And the other thing is that when you'd perform a calculation sweep, a permutation sweep of calculations, your brain's going to be like, I hate doing this stuff. I hate doing this stuff. You're having me doing it again and 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 again. I'm sick of it. Fuck that shit. I'm going to just memorize it. The brain will actually form. It's like I am going to grow a neural pathway to short circuit that calculation so we can jump over that fucking calculation. We don't have to do that calculation anymore. I have it memorized. We have the result. 341 415 926 535 897 922 384 66 433 82279. Right? Screw that. Screw the calculation. Takes too much energy. Faster to just recall it. That's how practice works. That's how this works. All right. So that's why we do parameter sweeps and we do the calculation so that we can recall it. All right. So let's do here. This is jumping ahead, but that's okay. We're going to jump ahead. Sure. Let's is my Oh, I see my okay, here we are. My stylus was mapped to the wrong monitor. Yeah. All right. So I mean, here, you can do something like this. You can go burp, burp. Right? Burp, burp. Beep, beep. Right? We're just literally taking one angle. We go up to like a 9-degree, right? I'm purposely leaving a gap in there. All right. And this is great because look, I can like now that I know, oh, right? Remember the box always has the opposite opposite. Look, I've got the top part of the box. Right? Boop, boop. We have enough information here to reconstruct information that ain't there. Boop, boop. Ain't that cool? That's fucking cool, man. That's super cool. So this is like a permutation sweep of like the top part of a box. Here's what's more. Here, we can take something like this. We can say, I can maybe take these two pieces, right? And I can just draw like a line like that. What can we do with that? Well, we can duplicate that and that. Well, we know all the, we can do same. Oh, look, this line. Same. Whoa, magic. Wait, let's do another one. Right, let's do a more 90-ish degree. So, well, we just same. Okay, so I kind of feel like, yeah. Oh, look, hey, we've got this. Moment I draw that, look, this line is same, right? This line, oh, same. That line, same. Aha. So the power of we're getting into extrapolation, all right? Interpolation and extrapolation. And this is the ability to take known information and to use that stuff to visualize unknown information or undefined information. Because, the moment you draw in like two lines, right, this immediately implies same. All right. Let's look at my agenda. I feel myself going, okay, right, yes. Interpolation training, perspective training, we've already kind of covered slightly those things. Yeah, let's talk about interpolation training for a sec though. Because no. Yes, I want the line tool. Okay. So this is a line tool, right? What is the wonderful thing about the line tool? Line tool means you get to say, I want my line to start here. And I get to say, I want a long line. No, I want a short line, right? I want a different angle. And this might be an exercise you can do on MS Paint, is literally just use the line tool and just say, all right, I'm going to draw like a square, not I'm going to draw a failure state. You need to see what a failure looks like. This is a fucking failure. But kind of isn't. But, you know, as a square, that's a failure. Okay, that is not some square. That's some kind of parallelogram. Not a square yet. Right? You want to be able to draw stuff that looks very same on all sides. And I'm even cheating using my wonderful crosshair to draw, you know, proper square. And I want to be able to draw a square that really, right. If I know this, if I draw it here, it's going to do that. That's not a proper right angle, right? No, I want to be about here, right? This takes a bit of calculation. This means you actually kind of have to look, and you got to say, it feels like it should be around here, and it's not even particularly great, but you'll notice how much like effort I put into trying to get it to appear square. This is not like when we're just kind of throwing lines out and being inaccurate. This is actually, you're going to have to train this. You're going to have to make this habit where you actually try to aim your lines. Think of it like throwing darts, right? We don't manage to land darts on the dartboard just by chucking them whichever way unguided, right? Or nor are you going to be able to like play golf and get the ball to go. You know, there's a lot of pre-visualization. You're trying to imagine, you're trying to see what something that's not there yet, and you're trying to like rehearse the thing and get the line to be accurate. And you have to treat every line like that. I know it's going to be really tiring. It's going to take a lot of energy, okay? But you're just going to have to do it. You're going to have to suck it up. You're going to have to do it until your brain decides, okay, I'll memorize this. Okay, that's training. That's training for you. You just have to do the hard thing until your brain decides to throw in a few neural connections to make it not hard. And there's a reason why I leave gaps, right? Is because the gaps, I mean, I don't have to be perfect. It just makes things easier, all right? So stop trying to be perfect. Don't try to make the lines like perfectly meet up on corners. If you have gaps, it's a little more forgiving. Your brain will be able to, will thank you for allowing you to save energy that way. All right, start with the line tool. Okay, just get into the habit of thinking the way that you're using with a line tool, and eventually you can have, no line tool. You can start, working with something like this. I just do a dot and a line, right? And I can, and eventually you can just go down to like working with just dots, dot, 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 right? This is even faster, right? So you're gonna have to train your interpolation, your ability to aim the line and decide where you want that line to go before you draw your line. Because when you know where that line's got to go, it's just a lot easier. Okay. Right. So that's a pretty good Popeye impression. Okay. Let's see. If you wanted to draw those boxes, by the way, right? Like if you can remember how we were doing that thing with this, right? The two flappy lines, right? Or you can do something like, that, right? Because those two lines go together and make that side of the box, right? These ones do it like that. There's a bit of a method to the madness. We draw an ellipse. We can say, same. Right? And same. Aha. This is the amazing thing. We can draw a dot here. Find middle. Same. Aha. Go through. Same. Boop. These shortcuts. This is why it's really good to be able to practice. Right? Just we're gonna right? Because now we can go, same. Same, 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 same. 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 No, hang on, wait. Oh, this one's really bad. Oh, this one's just awful. Hang on. Close, right? And there's nothing stopping you from saying, same, same. Sort of same. It's kind of hard to tell because it's getting really messy. I know, I should have been cleaner, but whatever. Same, 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 same. You can inscribe squares in any angle you want within those ellipses. So, kind of useful. You can also outscribe. So outscribe means, we take tangent. Yes, tangent. Tangent, good. Boink, boink, boink. You can outscribe. Outscribing is another way you can get this stuff done. So drawing squares in perspective, if you can draw ellipses in perspective, that can be expanded into doing squares in perspective. All right. So these are the Jedi mind tricks. Those are the Jedi mind tricks. All right. So this is stuff that I can convey to you through the transference of knowledge. But if we're going to start getting into actually learning, fucking learning perspective and learning the stuff that's really hard to learn. Okay. So I'm going to show you how to train that shit. I'm going to take this camera. No, we're not. Don't point it at my groin, dumbass. Okay. Jedi mind trick time. First, I'm going to have you draw square. Big square, right? We've been practicing square. Square, 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 square. Now we look at this thing from this angle, because chances are if you're not working with the monitor and you're working with like a piece of paper that actually allows us to look at this thing from different angles. It's like, look, that's a square, and we can shift the camera and we can see this thing at different angles. Isn't that handy dandy? All right, now here's another thing I'm going to do. Ooh, ew, hang on. I can see that my portrait camera is like freaking puny, and I'm going to fix that. Computer. Pause recording. Yeah, that's handy. Okay. So, yeah, we have this thing at a wacky angle. And right now, I'm not actually looking down at my piece of paper. I'm looking like at OBS. I'm looking at another monitor. And it's like a tiny monitor. Because when I do that, I'm going to be seeing things from an angle that you guys are seeing the thing at. And the goal is to take, we take this perspective. Look at that. Look at that. We can take this little edge here. We can even see the reflection in the camera. Oh, this feels so weird. Okay. So, you know what? Don't worry about drawing nice lines. You can draw them as like do a little piece and then move and do a little piece and then move and do a little piece. Okay, don't try to draw it as one line because, the hand-eye coordination is just really fucking weird, man. And then you can look back at your drawing and there we go. Good. This line is kind of going, oh. I can see the reflection. Okay, good. Now I can actually look at my monitor and I can draw that. Isn't that crazy? Like this is what it's like to draw like a 3D optical illusion, is that you like get in the habit of don't worry about drawing a perfect line. You can just draw like little pieces. Because if you try to draw a perfect line, look, when you try this, you'll really understand why I'm telling you to draw little pieces, because your hand feels so freaking weird. Oof. Ooh, feels weird. Feels weird. No, I don't like it. Oh, mo yamete. Yamete kudasai. Right, like I can draw like a shadow You know what? Maybe I will actually delete. We're gonna delete that bit. It's like I've carved a hole. I've carved a hole into my monitor, and now I'm drawing. This is the drawing of the illusion. Kind of cool, right? It's like this is how you learn perspective, is that you actually draw in perspective. We take this camera, we shove it over to a weird perspective, and we draw things in perspective according to that camera. We draw optical illusions, and it feels really freaking weird. And you know what? You're just going to have to do it until you get used to it, until it doesn't feel so weird. Because I want you to learn perspective and learn to actually learn perceptions, become aware of your own perceptions. We're turning a switch on. We're jailbreaking the phone. All right. We're trying to jailbreak your perception so that you ultimately have some control over them. All right. We're trying to go through the looking glass here. Oh, this is crazy. And just draw on little pieces. Don't worry about having perfect lines in this, because you know it's really hard, and I don't want you to get distracted. I don't want you to get distracted by trying to draw perfect lines. Not even necessary. It will hamper your progress. It will hamper your progress in this form of practice. All right, so I mean, I suppose, you know, we can try here. I can try. I'm going to try this. Oh God, I've never done this before. Oh, it feels awful. I'm trying to sync this back. Oh, it's just awful. Absolutely awful. It feels terrible. I'm going to cut a hole through that. And then oh, no. See the same thing. It's like you try to draw. I'm trying to draw a line, and the line doesn't go where I want it to go because I'm staring through a web camera picture. I'm not staring at my own hand. So all my previous hand-eye coordination training is just out the freaking window. And now it's like I'm trying to get that shadow maybe to feels weird. All right. But I'm treating this as like a kind of scaffold. Okay, yeah, let's sort of get rid of it. We're getting rid of enough information outside that, you know, the stuff that was throwing me off. And yeah, so I've cut a hole, kind of a circular hole. Oh, God. Awful. Gross, 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 gross. I'm trying to think, how far would that shadow go up? So this is why we use dots, right? The dots are just, they don't feel so weird. It's just that when you try to draw a whole line and the line starts to go in a direction that you don't like, it's very distracting. And if you need something to be darker, just draw more. Just draw more line. Oh, if you need less, then I can just right-click and erase. In fact, I think I need to erase on this side. Right? So just practice trying to make the illusion work. I guess maybe like drawing a big storm. This feels like I'm drawing like a big sewer grate or like a storm drain. Kind of cool, actually. Cool. Right? Drawing optical illusions. And I think this is probably the best exercise or the best kind of practice I can give to you, because it feels so freaking weird. It's like you're lifting a weight, and it's like the more you do it, the more when your brain has to struggle on a thing, the more incentive there is for your brain to create a neural pathway to make it easier. So, you know, when you take on whenever you do practice, you need to be practicing a thing where your brain feels significant calculation burden. Because if there's no burden, then there's no incentive for your brain to go in and start, you know, creating neural pathways. It won't perform neurogenesis. There's no Making new neurons takes energy. Brain suddenly has to fold. Brain like to be smooth. Brain no like fold. So that's why you can't get better just practicing a thing that you're already good at. You won't gain anything. You have to push yourself. All right. Yeah, so there's that perspective training. Right. I showed you that kind of, flippy stuff. It's like, yeah, we can and just take your angle and just let's reorient. I mean, I can really try to draw a donut from this perspective, from this. Ew, yucky, yucky, yucky. Yucky. I hate the feeling of it. Yucky. Okay, but that's what it means, is that the reason why that there's that feeling of yucky is because it's not the right way. Like I know that it's not. My pen's not going where I need it to, and I need to perform some kind of action to get it to go on course. There's a corrective action. It means my senses are actually kicking in and telling me that's wrong. This is the right way to go. It's like if you're driving a car and you're like, oh, we're going off into a ditch, and you suddenly had to perform some kind of corrective, action. That's great. That means that, your body is correcting things. You have to get used to that corrective action, because all of the drawing, like all of drawing when you're sketching and that sort of thing, you need to be applying corrective actions. Like you can't take for granted that you'll always be drawing perfect lines all the damn time, or that the things that you envision will come out exactly as you want. Instead, as you're working, there's this constant steering to steer yourself away from the ditch and back onto the straight and narrow. And so the more experience you have with steering the thing and fighting against the forces that are sending you off into the ditch, the stronger a draftsman you are. Like the really good draftsmen are absolute fucking monsters. They're big hulking, they're Hulk. They're like Hulk smash guy with giant perspective muscles and really crazy, perception muscles. And their muscles are so strong that even when their lines are starting to go off course, they can bend it back to their, using their sheer willpower and skill to bend things back on course. That's what you need. That's what the practice is. You're trying to bulk up. You're trying to get some gains. Okay, you're trying to get some gains so that you have control over this stuff, so it doesn't feel so yucky when you're like going off course. All right, that's what it means to really practice and to be able to get good at perspective. All right, there's not a lot for me to teach you in this realm. There's not a lot. Like there's that's it. Oh, it's like that. That's all a perspective. That's all the stuff I'm fighting for. Yes, but it's really hard. So most of the work is actually on you. I haven't taught you. I can't teach you perspective. I can only teach you how to teach yourself perspective, how to train yourself perspective, right? Like this is not something that can be done with a transference of knowledge. It requires just a lot of blood and sweat and tears and time. And you're just going to have to get up every day and get back in the saddle again. Okay. So you're going to have to practice this stuff until you hit your limit. You're going to have to be aware of your own internal tolerance for this kind of stuff. There's going to be a point where your brain just says, oh, I can't. I had enough. You can stop. Take a break. Play some video game. Play some video. Do something else. Give the brain a chance to get rid of some of the brain chemicals. Give your brain a little bit of time to origami itself, some more folds. All right? But you always come back to it when you feel like you're ready for it. You come back to it the next day, or you come back to it a few hours later, and you get on the horse again and you try it again until you hit that level of tolerance. Your brain's just like, I don't want to do it anymore. Okay. I do this stuff whenever I learn technical manuals, whenever I have to, I work with Unity. I have to read technical manuals all the damn time. And there's going to be times where I'm studying a technical manual and my eyes are literally just passing over letters, but nothing's sinking in. Like I'm just, that's a saturation state. That's a threshold state. I've reached my threshold. I've reached my tolerance level for learning. My brain's like, stop, I'm full. It just talk to the hand. That's when I take a break, play some video, do something else. Certain centers of my brain have basically burned out for a little while, and they need time to recover. I ran out of MP. Okay, I need to recover some mana. All right, so take a break, eat some food, whatever the hell it is, and then when you feel like you're ready for it, get back to it, because you just got to do a lot of this stuff to fold your brain appropriately. So I just want to say that everybody has their own internal threshold. I'm not going to say how much you have to do that. You have to do two, you got to do this 2 hours a day. You got to do 5 hours a day. It's like bullshit. You do it until your brain hits its limit, and then you stop until you feel like doing it again, until you feel like you can do it again. It's not like you're not going to feel like doing it. You're just, because it's a lot of work and effort, but you do it when you feel like, you can handle a little bit more, and you do some. All right. Learn to listen to yourself. Learn to listen to your brain's sense of whether it can or cannot. Get some self-awareness, right? Self-awareness means knowing when, getting that internal feeling for knowing when you're full. It's like, I should stop eating now because my stomach is full. It's like, I should stop practicing right now because my brain's hit its limit. Computer, end recording.